This third video will help you cover questions that involve bond enthalpy values. You will need to remember this formula. To work out the enthalpy of the reaction, we're going to sum together the bonds that you need to break, and then we're going to subtract off this subtotal of the bonds that need to be formed. This will make a lot more sense as you see me do these. Now, the reason you've got a big hunk of beef here is you do need to remember the order. That is the sum of the bonds broken, so B for beef, minus the bonds formed, and hence the F there. A little bit of humour. Okay, so first up, bond enthalpy is the energy required to break 1 mole of covalent bonds. These are data values that will be provided. You do not need to memorize them. It is worth noting that bond enthalpy values are always quoted as positive values, so it's the energy that you would need to break the bond. So they're always going to be quoted as endothermic, hence energy absorbed, and so the delta H is a positive value. However, keep in mind that if you are looking at the exact same bond, but you're trying to make it, then it would be the same quantity of energy, but it would be exothermic, because we know that bond formation is an exothermic process from our previous lesson. So I can't emphasize enough how important this equation is, and it is relatively straightforward to remember. Bonds broken minus bonds formed. Let's have a look at an example. So you've got here ethane reacting with chlorine, so those are our reactants, and we'll need to break all their bonds up so they can realign themselves and form these new compounds, chloroethane and hydrogen chloride. It is definitely worth drawing out the structural diagram so that you can see all the bonds that need to be broken. If you don't draw the reaction out, you may well have missed this carbon-to-carbon bond here. So inside this red box are the reactants, and we are going to sum together the energy to break all these bonds. Then we're going to sum together the energy needed to form all of these bonds. The values are always given to you in the question, so you do not need to memorize those. Let's start by summing together the bonds that we need to break. So carefully go around and add together how many carbon to hydrogen bonds there are that need to be broken. And if you add it up carefully, it's 6 carbon hydrogen bonds. Then we go over to this list and we can see to break 1 mole of those bonds requires 413 kilojoules per mole. However, we are needing to break 6. So we're going to need to use our calculator and take the 6 times 413 and get a subtotal there of 2,478. We repeat that for all the bonds we need to break. So we also need to break this carbon bond. It's just a single bond, so it is over on our list here, 347. I emphasize single bond because in some instances, if you need to break a double bond, it is a different value. It is not 2 lots of a single bond. It is not, okay? I'll point it out when we do another example that involves a double bond. And finally, we need to break this chlorine-chlorine bond so that those atoms can also be free to realign themselves in the new molecules. Take the subtotal, add these 3 numbers together, and you get the energy required to break all the bonds. On to part 2. These are the bonds that need to be formed. Now you'll notice that we need to reform 5 carbon-hydrogen bonds. It's not 6 because this has changed. So that's why it's 5 times 413 to give us our little subtotal here. We still need to reform the carbon single bond. We're going to now also form a carbon-chlorine bond. So that's a new bond that we're forming. Not that you need to know which ones specifically are the new ones. And this also is a new one, okay, that we are needing to form. We need to form all of them. And so you make a list and find your subtotal. Once you've got your subtotal, then we come back to this equation that you'll need to learn because it's not provided. You take your subtotal for the energy broken, so this is where the 3068 comes from, and subtract the subtotal for of the bonds formed, which is 3190. And your enthalpy for this reaction is negative 122. So for that reaction to occur, it is an exothermic reaction, which is what that negative stands for, and it will release 122 kilojoules for the reaction. Notice that we did not need to put a negative in front of our subtotal because the equation itself accounts for the fact that formation of bonds is exothermic and is a negative delta H, and that's why you have to subtract the formed bonds. So these questions are relatively straightforward, and plenty of practice, you'll become really good at them. I'll see you in the next video.